The chain rule. Hello everyone, welcome to Unique. In this video, we're gonna discuss the chain rules or the derivatives of composite function by using chain rule. Please be our family by subscribing this channel. Thank you for your support. Okay, chain rule is one of the most basic rule which is used to find the derivatives of composition functions when you deal with composition function. Let us start by defining this chain rule. If we have two functions f and g, psi f g is differentiable at x and f is also differentiable at g of x, then the composition of the two functions fog, that means f into g of x, f into g of x. Then if we have this composition, so how to find the derivative of this composition? So the derivative of the composition function by using chain rule, fog derivative at x means f derivative into g of x times g derivative at x. So by this way we can, or by using this formula, we can solve varieties of problems associated with composition function. So first of all, you have to derive f with respect to x, and then inside g of x, that means you cannot derive this, then you can multiply by g derivative at x. Here is a given equation or the formula for composition by using chain rule. So we can extend this for varieties of function. If we have three functions, the chain rule will be, let's we have f, g and h, three function, then their composition means fogo, that means f, g, o and h. We can see it later. So here important hints and examples in chain rule, we can find that the main problem in defining differentiating composition function is that what? Identifying f of x and g of x. To use the chain rule, there is a problem associated with identifying f of x and g of x. But we have different type of formulas and function. So by using different form of the function, we can easily use the chain rules. So for example, if we have this form, that means f of x is equal to g of x raised to n. Take n to the front end, multiply with g of x, then subtract 1 from the first term. So then multiplying the entire function, the derivative at x. Then this becomes the formula for this kind of derivative. Okay, for example, if we have f of x is equal to x cubed plus 1 is the power of 6. So what is the derivative? To find the derivative, take this 6 to front 6 times x cubed plus 1, that is g of x, then it is power is 5, then what? G derivative at x, that means g, our g is what? Entire function x cubed plus 1. The derivative of x cubed plus 1 with respect to x is equal to 3x square. We know that from derivative definition. So 3x square, here we have, then if this is constant, if we multiply this, it becomes 18x square. Then here we have 5, but here we have 4. This mistake or typewriter mistake. So we can find the derivative of this kind of form or equation, or this kind of function in this form we can easily find by this formula. Okay, let's try another example. If f of x is equal to under root of g of x, that means if we have this form, then f derivative at x means g derivative at x over twice of the original function, For example, if we have f of x is equal to under root of x raised to 4 plus 1, then f derivative means g derivative at x. Our g of x is what? X raised to 4. So g derivative at x means x raised 4 plus 1 derivative over twice of what? X raised to 4 plus 1. The derivative of this is what? 4x cubed. Then it becomes 4x cubed over twice of the original function, means under root of x raised to 4 plus 1. The original formula for this form of derivative. Okay, let's try another example. For example, f of x is equal to a raised to g of x. We have e, then again raised of g of x, another function. So we can find derivative by using this formula for this kind of form. For example, if we have a raised to x cubed, here our g of x is what? X cubed. then derivative will become a raised to g of x times g prime. That means a raised to x cube times the original function times the derivative of its exponent. So the derivative of our g of x is x cube, so 3x squared. 3x squared times a raised to x cube is derivative of this function by using this form of formula. Again, let us see another form of uh, function. For example, if we have f of x is equal to a raised to g of x, that means here we have a maybe any constant, that means it is exponential function, then we can use it or to drive the derivative formula for this. You can use this, that means f derivative at x is equal to a raised to g of x times g derivative at x ln of this constant, that means multiplying by ln of a. So that is the another form. For example, if we have for example, if f of x is equal to 2 a raised to x cube, then what is f derivative at x? F derivative at x will become what? The original function times, okay, g, that means our exponent, g derivative means what? 3x squared, then what? Ln of 2 means our constant, ln of a means our base, ln of 2. So it become 3x squared to x cube ln of 2. This is the solution for this, or the derivative of f of x is equal to x cube is what? 3x squared to raised to x cube ln 2. Okay, we have another form of function like f of x is equal to ln of g of x. If we give this kind of composite function or composition function, the derivative can be found by using this method. That means f derivative at x is equal to g derivative at x over g of x. For example, if we have ln of, this is what? Composite function, you know. We have inside ln 5x squared plus 4. So f derivative at x means the derivative of this 5x squared plus 4 derivative over the original function g of x. That means our entire function in the ln. So 5x squared plus 4, that means 10x over 5x squared 4. So we can use varieties of different forms of function to use chain rule. So chain rule is very important basic tool for composite function to solve that or to find the derivative of composite function. In this video, we discussed just a piece of basic idea about chain rule. If you are interested, please help us by subscribing our channel, support us. Thank you for your support, and keep in touch with us. In next video, we will see another basic interesting concept in mathematics or in other related fields. Please subscribe our channel and be our family. Thank you.